Do you believe her? Let me see your cantilevers. You tried them.
Yeah, this is the first homework.
Yeah, no, I just want to check cantilevers first, okay? And then I'll check the other one. Okay. Cantilevers first. Yeah. Where's cantilevers? Here, okay. Okay. Yeah. Okay. You have some more. Okay, so you drew them, but you had trouble with them. Yeah, but the picture's right, though. Let's see, cantilevers. Yeah, okay.
Only one.
For the second homework. Yeah, okay. Cantilevers, okay?
No.
Not okay. You have some of them. Yeah, okay. How are cantilevers? First one. Yeah. Okay, yeah. Okay, so they were okay?
Yeah, they are.
Yeah. How are you?
What is Deborah?
In cantilevers?
Yeah.
Yes, okay. Okay, some trouble, yeah? Alright. Right. I am going to do now the cantilever one first, okay? So, firstly, the girl opens a lid. So she has a force here, and you know that the distance is 0.04. So the turning force, the couple, is Fd, and I tell you that this is 1 Newton meter. So 1 equals F times 0.04, so that means F is 1 over 0.04, which is 25?
2.5.
25, I think. 25 newtons. Yeah? Okay. Number 2. I can scroll down? Yeah. Right, now, so now we're on to the more interesting ones, the cantilevers. So we have our wall and our cantilever. The beam here is, this is from here to here, 24 centimeters. From here to here is 10 centimeters. And then our stay is 26 centimeters. Okay, and then I also tell you the mass is 25 kilograms. So here is 25 G. So that means this is 12 and this is 12. Okay, so what's my question? Let's see. What is the tension? Alright, so first piece of business. I lost my colour pink. Well, I didn't think you'd like pink. Right, so firstly I want this angle here. I'll call it phi. So we have phi is tan inverse 10 over 24. Yeah. So let's see what we get there.
0.26 centimeter meters.
22 I got. 22.6 degrees. Yes? That's the angle. Now what I'm going to do is I'm going to resolve this into a horizontal and into a vertical. So this one here is T cos 22.6 and this one here is T sine 22.6 because here is the T here. So, Carrera, what are the forces which are going up? Oh, I'm sorry, actually, you know what, I forgot to include my reaction here. Yeah, so what forces are going up?
T,
Yeah, T sign is going up,
yes, and anti-clockwise.
and it is anti-clockwise, yeah, and then this one is going down, and it is clockwise, good. And we'll take this as the turning point. So, say again? I'm taking this as the turning point. So this one here is the, as you said, Gerardo, clockwise. Can you actually tell me how much it is?
1 10.
Yeah.
You want to convert centimeter.
Oh, these centimeters?
Yeah.
Well, yeah, I don't need to do the conversion to get the angle, but you're right, I will need to for the next part.
Yeah.
Yeah. So, Clara, could you tell me what this is, the clockwise one?
Clockwise, the 25G,
Yeah.
multiply,
Yeah, sure. I'm in no rush.
10,
Not 10, sorry.
24.
0.12. It's to here. Clockwise. And then the anti-clockwise, maybe you can tell me, KJ. The anti-clockwise? T sine 22.6.
Times 0.24.
Yeah. And this is in equilibrium, so the clockwise,
0.24.
it's 24 to here, from here.
You're taking this.
I'm taking the hinge as the turning point,
Yeah.
as the fulcrum. Right, so we have 25G 0.12 equals T sine 22.6 times 0.24. So now I have my T. Let's type it in. 25 times 9.81 times 0.12 divided by 0.24 divided by sine 22.6. And after all of that, I get T is 319 newtons. That's what I got. Did I type it in wrong?
Just type it again.
I'll do the same. Sorry, it's saying 319. Did you get that, guys? Did you get an answer? Did you get an answer?
No, I got the,
You got the angle? Good, but you couldn't get this part. Okay, so you were able to get to this angle here. Alright, do you know what I did now here? You sure? Okay. Can I go on to number 3 now?
why the clock is the way you multiply the rate?
Okay, yeah, that's
Why is the clockwise 25G multiplied 0.12? Yeah. Do you remember down here? This is called the turn-in force. And it's equal to the force multiplied the distance. So here, this is the force, and then this here is the distance. This here is the turn-in point. So this is making it turn clockwise.
Why is it clockwise?
This is a clock. Because, like, if this is the center and this is the hand, you know, here's the center and then here's the hand, and if I have a force this way, it wants to go clockwise. This is why it's clockwise. Yeah? Is that okay or not okay? You're okay with that?
okay. Oh, yeah. My calculator was in radian, that's why.
That do it, alright. Can I go on around this? Now, I don't want to go on if you still have a question.
The anti-clockwise.
Anti-clockwise is this one. Makes it turn anti-clockwise.
turning point is the same.
Yes, yes. The turning point must always be the same for the question.
Next question.
It's okay?
You guys know?
Yeah.
And teacher, always the clockwise is the weight multiplied by the half of the width.
Yeah, usually the weight is in the middle, which is half. If it's not in the middle,
So
then,
I have to...
yeah, if it's not in the middle, they must tell you in the question where it is. Yeah. It's usually the middle though. Yeah. Okay, can we go on to 3 now then? Yeah? Yeah, alright. So number 3. This one now is our first one with a strut. So there's this piece of wood here. I think it goes all the way to the edge. Yeah. Now the distances are 40 centimeters for. Well, you know what? I'm going to split it straight away into 2, 20 cm and 20 cm, and then this piece here, 50 cm, and yeah, actually from Pythagoras, if this is 40 and this is 50, you can use Pythagoras to get this one.
30.
It will end up 30. Yeah, from Pythagoras. Okay, what is the mass? It's 10, right? So here, 10g. Now, there's also a reaction force here. Yeah? And also here, it's kind of hard to draw. Actually, yeah, I'm curious, how did people draw the force here? So if you look at the last one, I called it T for tension. So in this one here, I'll just call the force F. But
Upward.
yeah, well, here's my choices. I can go up, I can go down, I can go right, I can go left, I can go at some angle this way, I can go at some angle this way, or this way, or this way. So my question is, which way? So you reckon up, yeah? What do you think, Tacken? Down, why not? Yeah, you said up, you said down, yeah, cover the bets. So Heath, what do you think? Your choices are up, down, left, right, or at an angle. You think left, okay. What do you think, Grace?
Right.
You think up, Amanda? Down?
Down.
Down?
At an angle.
What do you think?
At an angle.
At an angle? All of them at the same time? It's at an angle.
Downward.
No. What angle though?
It's upward.
You know, I don't know.
It's the straight line to the shape.
Yeah, so look here. This beam will be feeling the strut pressing into it. So therefore the strut, equal and opposite, Newton's third law, there will be a force this way, which we call F, and it's in the same direction as the strut. Now I understand why people said up, because it feels like it's like a table pushing it up, but it's actually pushing into it at an angle. It's not going straight up. You know, if it was like this, then it would be up. True? But because it's like this, then it's at an angle. Can you see that?
Yeah.
Yeah, and we're happy with this idea? Yeah, okay. So now what I need to do is get some angles. Okay, so this is S and this is S cos phi and this is S sin phi, and here's phi. And I need to find phi. By the way, phi will be the same as this angle. So we can say phi is, well, what would you say here, KJ? Well, what is it as a fraction?
Oh,
Was it, that's 30 or...
30 or 20.
Over 40.
40.
Yeah.
Yeah, that's fine. 36.87?
Looks like it, yeah.
Yeah, that was 36.8. Yeah.
Okay, so again, we'll use our turning force here. So we have, Amanda, maybe you can tell me what this one is, the clockwise one. From here, yeah. 10G, sorry, it's gone off the picture. 10G multiply 0.20. Okay. And then, Karar, could you tell me the anti-clockwise one?
Anti-clockwise, T sign.
I could, yeah. S sign, yeah.
S sign. 22.6.
Yeah, sorry, I should write in the angle, shouldn't I? What was the angle? 36.87.
You put 0.2.
I could, yeah.
Why?
0.20 centimeters.
Yes, and multiply 0.1.
There's no mention. Oh, okay.
0.1? Not 0.1. 0.
Half of 20 centimeter, right?
Oh no, 40. It's from here to here.
Oh, sorry.
Yeah. You're thinking of this one. Yeah. Okay, so we have 10G times 0.20 equals S sine 36.87 times 0.4. So we have our S now. 10 times 9.81 times 0.20 divided by 0.4 divided by sine 36.87. So the S is 81.7 newtons.
So the range is 20 or 40?
That 20 is already split in half because it was 40 and I split it into 20 and 20. See, I wrote it twice.
Okay.
Yeah.
If we use the force to be upward, we get 49.
Yes, which is wrong. So what's your point? Why is it this way? Why is it not straight? Yeah. So, here we have our table. So, if there is a force going down, the table is pushing up with a reaction force. And from Newton's third law, we know that the or must equal the W, and they must be in opposite directions. True? Okay. So what about this? If somebody pushes into the table here, then the table pushes back this way. True? Yeah? Yeah? Okay. Now what about this? There you are. Yes? And
It's like,
well, it looks like it. You're not moving, and there's a force being put into you this way. You are given a force backwards this much. So now instead of having you there, you can be a strut, and this can be like on top of a table. Yeah? No? Thanks. Where are you? Okay, let me try and draw it again. Think about it like this. Imagine instead that this was a spring. You know spring?
Yes.
So if I push down here, what will happen to the spring? It will get pushed this way. So the force is going in this direction, not this direction. this way. Yes? And then Newton's third law says that the reaction force must be opposite. So the reaction is going this way. The reason the reaction is going this way is because the force is going this way. And you can kind of imagine the force going this way because it's a spring. You know, if the force was going this way, then the spring would be, you know, moving down. I hope this helps. The other way, Amanda, the other way I think about it is, this here is really the same thing as this, just upside down. So if I draw the tension here, it's like drawing the reaction here. It's just upside down, that's all. It doesn't matter that this is a string and this is a beam. Yes, no, Fahad.
But it's still going wrong.
What do you mean?
If there's a gap, if you...
Oh, I'm not, no, come on, don't be ridiculous. I'm not drawing it accurately, you know that.
Can you go back to the question?
My answer? I can't even find it now. Here. Okay, number 4. Are you ready for me to do number 4? Yeah. Clara?
Yes.
Yeah.
Ready?
Okay, so number 4 is a little bit different because now you have not enough string. It is how much of a and the beam is 15 centimeters. Okay, so this is 15 centimeters, and then here is 5 centimeters, and then here to here is 12 centimeters, and the mass is 20. So this is 20 g. This here is your T. So this here is T cos phi, and this one here is T sine phi, and this is phi. Okay, so can somebody tell me the phi maybe? Do we have enough information for the phi? Yeah, what is it? Tan inverse 5 over what?
Well,
No, not 15 and not 12. Yeah, oh wait, hang on, what's 12? Hang on.
I think we have to get...
Why did I write 12? Sorry, that's 13, okay. Yeah, so what you don't actually know is, you don't know how big this side is, but you can use Pythagoras. If this is 5 and this is 13, then this side here is 12.
Yeah.
No, 15 is up to the end.
Yeah.
So tan inverse 5 over 12 is 22.6 degrees. Yep. Congratulations, you. So clockwise, it is, yeah, what's this distance here? From here to here. Here to here.
Like 3.
Nope. 7.5. Half of 15.
Okay.
0.075 times 20 g. And then the anti is what? What distance from here to here? What did we say that was? What did we say? We just said it a moment ago. It's 12. So 0.12 times t sine 22.6. So if you put these together, you get 0.075 20g equals 0.12 t sine 22.6. So I get t equals,
319.1.
well, I'll double check. 9.81 divided by 0.12 divided by sine 22.6. What did you say?
319.1.
319 newtons.
So also I think I can get theta from sine.
Yep.
sign there.
But because I haven't done that in math class, I'm just sticking to tan.
We did this here in physics class.
Did we use sign inverse? I thought we used
No, I'm not signing there, so...
That's what I'm saying, yeah. So, but you're right, you can.
Yeah.
Because then you don't need to get
Yeah.
the base. So that's fine, no problem. I'm just trying to keep it to tan because that's what we did.
Get used to it.
Yeah. Now I know I can see that some people have some trouble with this homework, but I hope it's, now that you've seen it, it's okay. Okay? Maybe. I can live with this. Okay, are we ready for the next one then? Yeah.